Here is a question that looks impossible at first. Find every pair of integers x and y that make this true. To solve it, we need to go back to the beginning. Natural numbers, integers, real numbers, Roman numerals, the rules that make arithmetic actually work, and 15 worked examples along the way. Let's begin. Every number you'll ever use belongs to one big family. First, the natural numbers. 1, 2, 3, and on forever. These are the numbers you use to count. Add 0 to the natural numbers, and you get the whole numbers. Add negative numbers, and you get the integers, the whole family of positive, negative, and 0. Add fractions and decimals, and you get the rational numbers. Some numbers can never be written as a fraction, like the square root of 2 or pi. Put rationals and irrationals together, and you get every real number there is. Today, our main character is the integer, so let's meet it properly. Before integers existed, ancient Rome counted with letters, 7 symbols. I is 1, V is 5, X is 10, L is 50, C is 100, D is 500, and M is 1000. Repeat a symbol up to 3 times. To add I means 3, but place a smaller symbol before a bigger one, and you subtract. XL means 50 minus 10, 40. Put it all together, and the year 1994 becomes MCMXCIV. Notice something missing. Rome had no symbol for 0 and no way to write a negative number. That gap is exactly why integers were such an enormous breakthrough. The clearest way to add and subtract integers is a number line. To add a positive number, you move to the right. Start at -5, add 8, and you land on 3. To subtract, you move to the left. From 3, subtract 9, and you land on -6. Right for positive, left for negative. That single rule solves every addition and subtraction of integers you will ever meet. Negative numbers are not just abstract, they're everywhere. A temperature of -10 degrees means 10 degrees below freezing. A bank balance of -$50 means you owe $50, and a depth of -200 meters means 200 meters below sea level. In every case, negative just means the opposite direction from 0. A set of numbers is closed under an operation if combining any 2 members always gives you back another member of that same set. Integers are closed under addition and multiplication. Add or multiply any 2 integers, and the answer is always an integer. But natural numbers are not closed under subtraction. 3 minus 5 is -2, and that's not a natural number. And integers are not closed under division either. 5 divided by 2 is 2.5, not an integer at all. This single idea, closure, is exactly why number systems keep expanding. Naturals needed integers, and integers need rationals. Commutative means you can swap the order and the answer never changes. For addition, a plus b always equals b plus a. For multiplication, a times b always equals b times a. But be careful, subtraction and division are not commutative. 5 minus 3 is 2, but 3 minus 5 is -2. Order matters. Associative means you can regroup the numbers and the answer stays the same. For addition, it never matters which pair you add first. The same is true for multiplication. Again, subtraction breaks the rule. Grouping changes the answer. The distributive property connects multiplication and addition. Multiplying a sum is the same as multiplying each part, then adding. A times, the quantity b plus c equals a times b plus a times c. The multiplication distributes into every term inside the brackets, like handing out the same gift to each person in the room. Integers also carry a few special properties worth knowing by name. The additive identity. Adding 0 never changes a number. The multiplicative identity. Multiplying by 1 never changes a number. The additive inverse. Every integer has an opposite that cancels it out to 0. And the zero product property. If two integers multiply to 0, one of them has to be 0. This one is the secret weapon for solving equations. Keep that last one in mind. We're going to need it very soon. Let's put all of this to work, starting with 5 foundational examples. Example 1. Classify 5, 0, -3, and 12. 5 and 12 are natural numbers. 5, 0, and 12 are whole numbers. All 4 are integers. Example 2. Ramesh has 45 marbles and gives away 12. 45 minus 12 equals 33 marbles left. Example 3. Temperature starts at -5 degrees and rises 8 degrees. -5 plus 8 equals 3 degrees. Example 4. Temperature starts at -2 degrees and drops 5 more degrees. -2 minus 5 equals -7 degrees. Example 5. A submarine at -450 meters rises 200 meters. -450 plus 200 equals -250 meters, still below sea level. Now let's see the properties themselves at work with real numbers. Example 6. Commutative addition. 7 plus -3 equals -3 plus 7. Both equal 4. Example 7. Commutative multiplication. 6 times -4 equals -4 times 6. Both equal -24. Example 8. Associative addition. Grouping 2 and -5 first, or -5 and 8 first. Either way, the answer is 5. Example 9. Associative multiplication. Regroup however you like. The answer is always -30. Example 10. Distributive property. 6 times the quantity 10 minus 4 equals 6 times 10 minus 6 times 4. Both sides equal 36. 4 more examples built on the special properties. Example 11. Closure. 3 minus 5 leaves the natural numbers entirely, and 5 divided by 2 leaves the integers entirely. Example 12. Identity. -8 plus 0 stays -8. -8 times 1 stays -8. Example 13. Inverse. 15 plus -15 cancels perfectly to 0. Example 14. Zero product. If x minus 3 times x plus 2 equals 0, then either x equals 3 or x equals -2. That factoring trick, turning an equation into two things multiplying to 0, is exactly how we're about to crack our opening puzzle. Finally, back to the puzzle we opened with. Find every pair of integers x and y that satisfy this equation. Move everything to one side. xy minus x minus y equals 0. Now add 1 to both sides. A clever setup that lets the left side factor perfectly. The left side factors into the quantity x minus 1 times the quantity y minus 1. Now we use the zero product idea from before, but for integer factors of 1, two integers multiply to 1 only if they're both 1 or both -1. That gives two solutions, x equals 2, y equals 2, or x equals 0, y equals 0. Check it. 2 plus 2 is 4, and 2 times 2 is also 4. 0 plus 0 is 0, and 0 times 0 is also 0. Both work perfectly. Those are the only two integer solutions in existence, and we found them using nothing but the properties from this very video. Look how far we've come. Natural, whole, integer, and real numbers. Roman numerals and why they needed replacing. Addition and subtraction on the number line. Closure, commutative, associative, distributive. Identity, inverse, and the zero product property. 15. worked examples, solved with no mistakes. Subscribe for more number theory made simple.